Thanks, Rob. Um, as you heard, I work at ICANN. ICANN is the Internet Corporation for Assigned Names and Numbers. Not just me who's here from ICANN, we have two colleagues. David Huberman and Gabriela Schitek are here as well. They're from our engagement team. So today, if you have any questions about ICANN, about Internet in general, things that you do not know, which is unlikely because you are here, feel free to come up to us. We'll be here. We'll be tonight at the social. Buy us drinks. It's probably free. But anyway, I'm going to talk about extended error reporting, but this is basically a journey over the last 12 years, and it started in 2010. I got a phone call. I was working at Nominet. Nominet is a .uk, similar to the Internet Foundation here in Sweden. And I got a phone call from my boss, Simon McKellar. He's the CTO. He was the CTO. He's moved on since. And he said, I've got this guy who writes on Twitter something, and he says, the .uk ZSK rollover appears to have gone wrong, and we need to restart caches to flush out the old ZSK. Sad smiley, #fail, #DNSSEC. And I'm telling Simon, this guy is an idiot. We did a key roll 2 months ago, and our next key roll, the ZSK, will be in a month. Right, so nothing's going on, it's all fine. So don't worry about it. And Simon says, oh, that's good. That's good to hear. And I'm like, so who was the guy? Who said that? And he said, Anand Budev from RIPE. Now, whom here knows Anand Budev? And I would like to see some hands. All right. So for those who haven't had your hand raised, Anand is a long-time DNS engineer, a senior engineer at RIPE. Right? He's very good in what he does. He's very knowledgeable. But one thing you really need to know about Anand is one of the kindest people you will ever meet. Right? He's one of the warmest, kindest. He's really good at Scrabble as well, but that aside. Right? When he writes something like this, you stop and you check your DNS. And I did. And initially, I couldn't find anything. I checked our DNS, right? You open up your laptop. DNS geeks know how to use dig, right? You do dig. And I checked the UK zone, and it looked fine. And I validated here and there a little bit. It all looked fine. And so I didn't know what was going on. I knew that Anand was right, so because he would not otherwise say anything like that. So I called up one of our DNS engineers at the operations team. Now, a long time ago, I used to be in operations, and then they found out how I configured stuff, and I moved on to be a developer. Then, when I was a developer, they saw my code, and then I became a researcher. This is the path, and when I say research, it's mostly statistics and engineering. But so I talked to one of our operations guys, and I know how they work. As I said, I've been one. And is there anything going on with DNSSEC, with our signing system over the last week or something? Maybe you could tell us? Oh yeah, nothing really at hand. On our main system, we had a kernel panic, which happened, which is fine, because we have a fallback system. We are doubting on Friday evening if we should reset the main signer. In DNSSEC, you have a signing system, right? And if you know what you're doing, you have another one as a backup, fallback, right? And we use it as a hot standby. The other signing system, the fallback backup, doesn't know if it's the live one or not. It's just always live. In general, we use the main signer to sign, to use that information, but the backup signer would always sign as well. So on Friday evening, they decided, this can wait. Because if we reset the system, we're going to reset the HSM. If you reset the HSM, you need to have what is called a security officer or a crypto officer to type in a special code in the HSM. There's a good reason for this, right? Because someone might come into a data center somewhere, take your HSM, take it home, right? And try the code and just switch it on if you don't have a security code. And you don't want that, so you need to have a security officer. This was Friday evening, it's really late. The security officer, those who have access to the HSM, is Nominet's senior management. Right? This is how you do stuff. When you want senior management to be aware of what's going on, you need to give them a code, you need to have them actually take responsibility for things. And that worked well. Except this was Friday evening. This is England, in a pub. So, and you know what? the signing system can be put on hold. We are using dynamic update, and we could hold the dynamic updates to our main zone for quite a while. Even better, this was the .uk zone. If you know the UK deployment a little bit, it's UK at that time, right? It's .uk, and under it is .co.uk. And we hadn't signed .co.uk yet, just a little .uk zone. So it's fine if it's not signed for a day. This can wait until tomorrow. All right, so the next day, Saturday, when this incident happened, it was decided to fall back to the live system, otherwise someone had to go to the main signer and type in the security code. You don't have to, we have a fallback, it all works. It's also a great test. Anyway, the failover worked, right? In this secondary system, in that other system, there was a KSK that signed the key set, including the ZSK that signed the zone. Everything was perfect, everything worked. Except when we rolled the ZSK 2 months ago, that new ZSK could not be written to the file system because of some silly user setting rights. It's very naive. We know better now. Well, they know better now. I've left since. But that still had the old ZSK. Normally, this is not a problem, except when the entire world has cached this ZSK and is trying to validate with, signed with this new ZSK, right? So this is mismatch. Caches will fail. Validation will fail. And the embarrassing thing was, we had to find out, thanks to Anand, this over Twitter. So this highlights the 3 problems I want to talk about. Number 1 is DNS problems are not obvious to the end user, and I'll get to that in a second. And with end user, I'm not just talking about people using their home systems and just doing their normal internet thing on their mobile or whatever. I'm talking about DNS experts as well. DNS problems resolved at a resolver, right, do not automatically get reported to where they can be fixed at the authoritative server. And the last one, which I also think is really important, real-world, risk-free testing with DNSSEC deployment is not possible. You can get very close, but you can't actually do the real-world testing, at least not risk-free. All right, so let me start with the first problem. DNS failures are not obvious, right? It often manifests in when my mom calls me, the internet is down, right? It's probably the ISP's resolver that doesn't work or something like that. But what you get as a DNS engineer when you do a dig for something where the validation fails, right? You get a surfail. Surfail hides every mistake. Right? You have to dig deeper. You have to go to the authoritative server. You have to figure out what's wrong. Surfail hides things like lame delegations, missing glue, and of course DNSSEC validations. And so within the IETF, the Internet Engineering Task Force, a couple of years ago, we started to work on something called extended DNS errors. And you can try that for yourselves. Those who are with a laptop right now who know dig, right, you can just type in dig at quad1. I think that's Cloudflare. And try dnssec-field.org. I'm not sure if it's visible. What you see in red on the screen is this extended DNS error. And it nicely informs you that, hey, there's a DNS key missing. That's an actual error, error number 9 in the extended DNS errors. The original error is still there. It says surfail at status, right? So this is surfail, one that you've always gotten, right? When you try DNSSEC field. But now you have this additional message. The string in the back, no SEP matching the DS. SEP stands for secure entry point. No secure entry point matching the DS found for dnssecfield.org. Now this last part, that string, this sentence, that's something that the validator operator or the validator developer has put in. But 9 is the official error code. It's not just 9, there exists like 27 at the moment. There's one very funny one that I actually didn't think about that at all. There's a signature expired before it's valid, right? And I only discovered this the other day, that is now part of the error codes. So what this is basically when a signature in DNSSEC has a start time, it's valid from now until then. These are just dates, right? And you can accidentally turn them around. And I never thought of that could be an error, but it is now. So I love that. Anyway, so it's in active development. This registry this is an IANN registry. It's open. If you find a new type of error, you can just ask for a new typecode for this. But that leads me to the second problem. And this is stuff that we are working on now. So RFC 8914, that was in the past, that's done. And this is what we're doing now. Failures do not automatically reach the place where they can be fixed. And if you think about it, right, there's this whole disconnect between authoritative server operators, right, on one side, and on the other side, resolver operators. Authoritative server operators, domain holders, brand organizations, a lot of presence within ICANN, for instance, within the ICANN community, right? And on the other side, resolvers, that's mostly ISP, internet service providers, or companies having their own resolver, right? So there's this non-overlap. The only overlap, the massive overlap between the two that you will find are the developers, right? Most of the developers who've written a resolver has written an authoritative server as well. All right, the solution to this problem is actually straightforward. The problem of fixing things where they can be fixed, reporting it to the place where it can be fixed. Right? The domain owner, on the authoritative side, it publishes a place where to report errors. And we'll get into the technical part in a minute. And on the resolver side, you basically, if you find an error, you will send that to that place you've just received, where to send errors to. Now, initially it might seem naive, but I will go into the details in a minute. But this is not an original idea. In the world of spam and email, you have something called SPF and DKIM. SPF stands for Sender Policy Framework. And the idea behind SPF is basically, I publish in DNS a place where I send mail from. If you receive mail from anywhere else, ignore it. That's not me. That's Sender Policy Framework. DKIM, domain keys in mail, it's basically a public key that you can use to authenticate that I sent that mail. So I publish this DKIM key in DNS, and you can check it. Now, that has the same problem in DNS, right? On one hand, you send the mail, right? And here you validate that mail. And what SPF and DKIM said, right? If the signature is invalid, drop it. Don't send it. Don't send it to the end user. Right? The MTA needs to drop the mail on the floor because it might be spam or worse, right? Now, what about misconfigurations? These happens as well, right? And we've seen a few in DNSSEC, and I'll talk about that in a minute. With SPF and DKIM, for instance, if you have this important mail you want to write, yeah, and you let's say for work or for when you're a student, and you send this just before the deadline, whew, it's done, it's over there. But then, because of a configuration failure, the mail message is dropped on the floor. Right? You have really no proof that you sent it, and they have really no proof that they've received it. Right? It's somewhere stuck in the log somewhere. In comes DMARC. I forget what DMARC stands for, but you can look that up. But DMARC is nothing else than basically saying, you validators or mail transfer agents, when you check this SPF and DKIM stuff and you happen to throw this stuff on the floor, right? Also, please send a report to the sender. Now, this is very interesting, right? Because now all of a sudden you have these anti-spam organizations, right? Brand protection agencies, etc., who can now see who's trying to spoof their customers' domains, right? And send mail on their behalf. So now you have companies like DMARCian and PowerDMARC, and there are a few others. ValleyMail does it as well. That use this record to get information about the brands they are protecting. So error reporting will do a similar thing. So this is how it works sorry, I literally talked about. Let me talk about the failures that we've seen in DNS. So I talked to you about the error that we had in 2010. Luckily, hardly anyone was validating at the time. Now this is a different era, right? We have a lot of resolvers validating. We have a lot of DNSSEC deployment, and recently, .NA had an issue with DNSSEC. Also in Sweden there was an issue. Here in Sweden was an issue with DNSSEC not so long ago. It would have been nice if you got that report immediately, right? And not through other channels. So how does it really work? Now the authoritative server sets an eDNS 0 option, extended DNS option. A new option that basically says, send error reports over here to this domain. The domain in this case is reportingagent.example. Now this authoritative server over here is responsible for the domain test. And then when there's an error here on the validation side, the validator checks or the resolver checks and there's something wrong. Let's say a DNS key is missing, similar to the one in the example that you saw before. If a DNS key is missing, what you can do is you prepend that error code, 7 in this case, to the type that you're asking for, type A, that's type 1 in DNS. And then the host name you're trying to resolve, or the domains that you try to resolve, in this case broken.test, and you encapsulate that with _ER on either side. You need to do that, and this has something to do with how do you do domain shortening? What resolvers? I forgot the term. QNAME minimization. That was it. Has something to do with QNAME minimization. So you need to encapsulate that in order to see what was the full string that's being sent, and you simply append reporting-agent.example to that string. Remember the string you've learned as a resolver from this eDNS message. And you just send that query out. You send this query out, _er.7.1.broken.test _er.reporting-agent.example. Okay, in hindsight, I should have made it shorter. But when you send it out, it magically ends up, right? This is how DNS works. The query magically ends up at reporting-agent.example. Now the resolver or validator just fires this query and forgets, right? It will get a response, right? And it can cache that response that will dampen the amount of error reports sent, right? But this is basically how it works. So how is that going within the IETF? So before we wrote this idea up in detail, we talked to a few resolver and authoritative server developers, people like ISC that are responsible for bind, and people like Netnod Labs, they're responsible for NSD and Unbound, and the Power DNS people. And the overall feedback to that idea was positive. So in the IETF hackathon, the people from Netnod Labs developed the authoritative side, which is, to be honest, the simple side. But it's just another eDNS 0 option that you can implement. And that worked. The issue for the resolver side is that it depends on RFC 8914. Remember the extended errors we talked about before? That's what it depends on. So we're now in a situation, it's in various stages by various developers. There is a running code, there's rough consensus. We will hopefully in the London IETF do some more work on this, but the draft is fairly stable. We had a deep-dive working group. That's a different working group than the DNS operations working group. We had them showing interest in the way this works. So there's quite an amount of interest in this. All right. Now the third problem. Remember that we talked about this? How can you test DNSSEC deployment risk-free worldwide? I'll tell you why that's not possible currently. Because a lab environment is not the real world, right? And you can think of all the possible scenarios, and I promise you, right, a scenario will develop that you haven't thought of. New algorithms might be deployed, and not everyone has implemented it, and not everyone has implemented it correctly. Environments change. You might do a ZSK rollover, KSK rollover, a DS rollover, a hash algorithm rollover in the DS record. Environments change. You might go to a different service provider. You might have a different signing operation, a different signing provider, etc., etc. All these things evolve. So you can't really do this in a lab environment. So some folks came up with dry run DNSSEC. Now, dry run DNSSEC is a trick, and it's actually a cool trick. What you do is you do DNSSEC validation as a validator, right? Like you would normally do. But if there's an error, you won't tell your client. You just send whatever they're asking for, send back as if there was no DNSSEC validation. So you're lying, basically. But remember, this is a dry run, so not a real DNSSEC deployment. So I didn't say this is risk-free. I didn't say this is real world, but it's near risk-free and near real world. So when that happens, and together with the DNS error reporting, you can now have validators around the world send back error reports to you. So you're going to test with this new algorithm that hopefully a lot of people have deployed, but you don't know until you real world test it, right? You have this special signal that this is a dry run, and then you just wait for the reports to come in. So this idea is currently proposed in draft Yorgos DNSOP dry run DNSSEC. If you're interested, you can look that up. It's fairly technical. We're currently still designing the system, so there's a little bit of a debate on how to signal this. Right? How can you signal that this is dry run? And you only have a few bits to work with. For instance, do we use a new DS type? Do we call it DDS? That's an option. Or do we use one of the bits in the DS digest type? Currently we have two digest type 1, type 2, right? This is an 8-bit field, 256 possible uses, so there are a few types to burn there that we can use. So all of this is still being discussed. We haven't asked the working group yet to adopt this as a draft. So a little bit about process within the IETF. The way it works is if you have an idea, if I have an idea, if my sister has an idea, if my 7-year-old has an idea, she can write it up and send it to the IETF, right? Now, if you get enough support on this, you get a few people helping you to write this stuff up. And then you can go to a working group within the IETF and ask them, if this is interesting, could you please do a hum? Right? It's not really voting, but you can gauge interest that way. You can measure interest that way. And if they like it, they can adopt your draft as a working group draft. And then if you're still interested in continuing, you become the editor of the draft, or the author of the draft. You will have less power to steer things, if that makes any sense. So it makes sense to, if you have a good design in mind, to test it with friends first, which is what we did. So, make a long story short, the 3 things that I talked about is, first, extended DNS, RC8914, right? How to get more granularity in error detection. Number 2, and that already exists. There's nothing we need to do there. You can use it today, as you've seen. The second thing we're working on now is DNS error reporting, right? Getting the errors to where they can be fixed, right? And if you guys, any of you, if you are an ISP, if you're a registrar, if you're interested in this, I'm around all day. Let's talk, right? Because we need all the help we can get. Yesterday, I talked to DNS Labs, a person from DNS Labs, from the Internet Foundation. I think they're very interested in this at the moment, so we'll continue talks with them as well. NLNet Labs is involved, and NLNet Labs are responsible for Unbound and NSD. And of course, ICANN ourselves are involved. What that means is basically I lent my time to help the working group standardize this. That doesn't mean that ICANN deploys things. We don't do anything without our members wanting things, if that makes any sense. So take that with a grain of salt, right? That ICANN is involved in this. It means I'm involved in this. The last thing, dry run DNSSEC, that's all very new, it's very experimental, it's very exciting, right? It's very promising as well. And so that's something to look forward to in the future. Anyway, that's my 20 minutes, I think, 25 minutes. How are we doing on time? All right. Any questions? Please feel free to ask. In essence, Myself, my colleague David Huberman, if you please stand up for a sec. This is David over here, hands up. And this is Gabi over there, Gabriela Schitek. They're part of our engagement team. They're here all day and there for you to talk to if you want to know anything about ICANN. Thank you.
We have a few minutes. Any questions? No? Okay, thank you.